In this video, we're going to be solving a 3x3 system of linear equations, and this is going to be the second type of problem. For the first type of problem, check the description, and I will link that video there. Okay, so on this one, we're going to have some missing variables, unlike the other ones that we did. So in this one, we're missing an x, and this one, we're missing a y, and in the third one, we're missing a z. So how do we solve this? Well, what I'm going to do is solve the first one for y, and then solve the second one for x. They will both then be in terms of z's. The z's will be on this side and the x and y will be on the left side. And I can substitute in for both of these and solve for z. Let's show you. So for the first one, I want to solve this for y. So I've moved that y over by subtraction, or the for z rather, and it becomes negative 4z minus 14. Okay, that all I did was subtract 4z to the other side. And the x, I'm going to do the same way. I'm going to subtract 3z to the other way. So x is equal to negative 3z minus 8. Okay, so we'll label these 1, 2, and 3. I'm now going to look at equation 3 and notice that I have an x and a y. Well, I have an x and a y here, both in terms of z. So in place of 2x, I can write 2 times the x that I have, negative 3z minus 8. And for this one, negative 3y, I can write negative 3, and then this stuff here, minus 4z minus 14. And then the other side is equal to 8. Okay, so notice that we have all z's and numbers this time. So we can solve this and get an actual number. Let's distribute. So negative 6z minus 16 plus 12z plus 42 equals 8. Okay, so 12z minus 6z is 6z. 42 minus 16 is, let's see, 28. No, 26. Okay, so plus 26 is equal to 8. Okay, I subtract that 26 to the other side, and I get 6z is equal to negative 18. And when I divide by 6 on both sides, I get z is equal to negative 3. Okay, so now that I've got one solved, notice these up here are both solved for z. So all I have to do is figure out x and y is plug in the z values for those. Okay, so for the y, it'll be negative 4 times negative 3. That's where the z goes, minus 14. So that's y is equal to 12 minus 14. Y is equal to negative 2. X is equal to negative 3z, so negative 3 minus 8. X is equal to 9 minus 8. So x is equal to 1. And we had the ordered triple of 1 for x, negative 2 for y, and negative 3 for z. Okay, on this one, only one of the equations is missing one of the variables. The bottom one is missing the x. Okay, so how are we going to go about solving this? Well, let's add the top two. Let's label them first. If I add these top two, the x's will cancel out, right? The negative 2x and the positive 2x will cancel. And then we'll have, when we add them together, we'll have another equation that both has a y and a z. And if you have two equations and two variables, you can solve that. So I'm going to add 1 plus 2 together. So if I do that, negative 2x and 2x cancels. Y minus 4y is negative 3y. And then 2z plus z is plus 3z. And when I add these two numbers together, I get negative 3. Okay, let's clean that up by dividing everything by negative 3. So that gives me y minus z is equal to 1. Okay, so we'll call this equation 4. Now I'm going to take equation 4 and equation 3, which is y plus 4z equals 6, and I'm going to use those to solve for y and z. So how would I do that? Well, I need to make these opposites. It's already got y and y here. If I could just change one of those signs by multiplying by negative 1, then those y's will cancel and leave nothing but z. So let's do that. So that will give us y minus z equals 1, and negative y minus 4z equals negative 6. If I add those straight down, the y's cancel. I get negative 5z and equals negative 5. Divide the negative 5 on both sides, and I get z is equal to 1. Okay, now that I know z is equal to 1, I can use this equation number 3 here that says y plus 4z equals 6, but instead of a z, I'm going to write what I found z to be, which is 1. So y plus 4 equals 6, subtract the 4, and I get y is equal to 2. Okay, and now that I have both y and z, I can use those two to plug into either one of these, it doesn't matter which, to get my final solution. So let's use the first one, negative 2x plus y, 2, plus 2z, so 2 times 1, z is 1, okay, equals 12. So negative 2x plus 4 equals 12. If I subtract the 4 from both sides, I get negative 2x equals 8, and divide the negative 2, and I get x is equal to negative 4. Okay, so that will give me the ordered triple of negative 4, 2, and 1. Okay, in this problem, we see the top and the bottom one are both missing a variable. The top one is missing a z, and the bottom one is also missing a z. Well, that's good for us. If they're both missing the same one, that means that we can use those two equations to solve x and y. Okay, so we'll call this 1, 2, and 3. I'm going to use 1 and 3, so I have 2x plus y equals 5, and I have negative x plus 4y equals 2. Okay, I'm going to use elimination. So I'm going to have to multiply this one by something that will be the opposite of the 2x. So I can multiply it by 2 because it's already negative. So the top one is still 2x plus y equals 5. The bottom one is negative 2x plus 8y equals 4. Add those down, and as expected, the x's cancel, and you get 9y equals 9. Divide by 9, and you get y is equal to 1. That's our first solution. Okay, if y is equal to 1, we can plug it into either one of these and solve for x. Let's use the third one. So the third one is negative x plus 4y, but instead of a y, I'm going to put 1 equals 2. So negative x plus 4 equals 2. Negative x, if I subtract 4 from both sides, equals negative 2. So x equals 2. Okay, so I have x and y, and I only have one equation left to use, which is the one that has all three. Okay, so I'll plug in 3 times x, that's a 2, plus 2 times y, which is a 1, minus z equals 10. So 6 plus 2 is 8, minus z equals 10, and subtract that, 8. So I get negative z equals 2. So z is equal to negative 2. So my ordered triplet is 2, 1, negative 3. Okay, for this problem, kind of like the first one we did, all three of them are missing a variable. This one is missing an x, this one's missing a z, and this one's missing a y. So we're going to go back to the same strategy that we did the first problem. I'm going to solve this first one for z, and I'm going to solve the second one for y. So let's label those. Okay, so 1, if I solve it for z, I would have to add 2y to both sides. So z is equal to 2y plus 7. So I added it over to the other side. And 2, I would have to subtract the 4y. So x is equal to negative 4y minus 14. So that's 2. Just solve for z on 1 and x for 2. Okay, so why I did that is because now I can take these two values, z and x, and put them right here into x and z. Okay, and I'll have everything in terms of y. So 3 times x, which is negative 4y minus 14, minus 2z, which is 2y plus 7, equals negative 8. Let's clean this up a little. So negative 12y minus 42 minus 4y minus 14 equals negative 8. Combine our y's, so I get negative 16y. And here I get, what is that, negative 56. So minus 56 equals negative 8. Okay, when I add the 56 to both sides, 56 minus 8 is 48. So I get negative 16y is equal to 48. Divide the negative 16, and I get y is equal to negative 3. That gives me my first solution. But it also is pretty much giving me my other two solutions too, because I've got z solved for y, which I now have, and I have x solved for y, which I now have. So I can plug those in. So for 1, it'll be z is equal to 2 times negative 3 plus 7. I'm using this one. So z is equal to negative 6 plus 7, which is 1. 2, x is equal to negative 4y, which is negative 3, minus 14. So x is equal to 12 minus 14. So x is equal to negative 2. Okay, and that gives an ordered triplet of negative 2, negative 3, and 1.